Welcome back to a lecture series on digital image processing, principal component analysis. So in this exercise now we are going to discuss about the principal component analysis, how to do the PCA analysis in the NV platform. Once if you open the window, you will have to add the data. Now we are adding the data of the Sundarban region. And it has got, now you are bringing your full screen view, and now go to the data manager, and you just check that you have 4 data, blue, green, red and near infrared region of the data sets. And after that, after exploring the data sets and its availability or the presence of the data which is there, now we have to reduce the data set, data redundancy or data correlation by using PCA, basic principles of principal component analysis, is the orthogonal transformation technique that is preserving the symmetry between vectors and angles to reveal new set of data, arguably better than your data sets, like better from the original data set and better capture the essential information. It means better interpretation as well. It happens often some variables are highly correlated and some variables are not highly correlated. So that also we can be able to take the duplication out. Instead of discarding the redundant data, PCA condenses the information in intercorrelated variables into few variables called principal component. Now let us see how this is being done in the NV platform. You have to select the tool for the PCA. You take the transformation PCA rotation, and in that you have to take the forward PCA rotation tool. Now this tool is principal component input file tool. There will be select input file tool and file information tool. You have to select the data and subsequently give OK. Once if the forward PC parameter toolbar appears, then here you have to give the output file name as PCA stat. Now give OK, and after selecting PCA OK, choose the output file name as PCA.data. Now you are going to get the statistical output as one output, and the data is the another output. Right? You have 4 number of bands you are using for your PCA studies, band BGR and IR, infrared regions. So all this is required to correlate each other and to bring the databases together into a common platform. Right? To understand or to reduce the data sets. Once if you give OK, the principal component rotation process started. And once if it is started, you will be able to get the eigenvalues. It means the eigenvalues of the x-axis over the eigenvalues on y-axis, the PC eigenvalues, where it relates with x and y also will be able to understand through this. Right? Once if you open remove the data source, and then you have the PCA band now you can check or load all PCA output, PC1, PC2, PC3, PC4, and in every PC output we will get the informations. Like you can check in, check out, you will be able to understand that how PCA is correlated to the data and data is reduced in a single band to give the information in a better way. The main idea of PCA is to reduce the dimensionality of the data set consisting of many variables correlated with each other, either heavily or lightly, while retaining the variation present in the data set up to a maximum of extent. This is how we do with the PCA, and once if you do it with PCA, you will be able to get your all the output. Or you can correlate, you see the PCA1, PC1, PC2, it interacts with the other band data and gives classical output. 1 minute, I'll just give you better results. Once the layer name as mentioned 1, 2, 3, observe the variation in shades. You see you have a black and white. As we change each panchromatic layer, last one is the last one which what you are seeing is the band BC4 is infrared band. That's why it looks like larger granular material. That's why you won't get much of the information from this, right? And you similarly notice how the image display is varied in shades. That is very important. If you click every image shades are changing. These shades, based on the shades, somewhat losing details, revealing a new aspect, becoming grainer granularly as we move towards to the seventh layer. The last layer is better, whereas the layer 3, I mean layer 7, this is the layer 7 is better because that gives you clarity, discrimination between the water body as well as the land information. Whereas the other one PC, the other which you can see the granular, I mean the pixel representation is not correlated perfectly. So this what is happening here in PCA, it reduces the data sets and then bringing the correlation together and then reducing the data quantity in terms, and this gives you better interpretation for the scientist whoever is working with the image processing technology by using the satellite images. Now you can open one by one and you can check, right? PC band, PC band 1, PC band 2, PC band 3. PC band 1 is infrared, PC band 2, 3, 4 is your what is that? Your blue, green, and red portions. And now you take the printout and then you just start. I mean, take it into your platform and then digitize, interpret well for your subsequent studies. And these grayscales are varying from 1 to 1. That gives a lot of ideas or the interpretation for us, and you can make it zoom and then maybe you use for the further studies. With this, the discussion on principal component analysis is come to an end. Thank you very much.